So last time we actually finished this one. That's scary, right? So which is awesome. But I thought I'd talk to you about, before we move on and talk about the test, just some variations in substitution. This might help you on this final, but it'll also help you in Problem 2 if you know these little tricks about how you can do things differently. So say, for example, let's look at this integral here. So now, this is an integral. It doesn't look like any of our basic rules, right? It doesn't look like a power rule. It doesn't have sine or cosine. So substitution is the only other thing that we know so far that can do integrals, so that's what we'll use, right? But I wanted to do the variation where you have limits. You have a definite integral that you want to do by substitution. And there are various ways you can attack this problem. So, method 1. You basically ignore the limits till the end. This is one way to attack this integral, right? So let's actually do this integral. What would we substitute? Equals 16 plus x squared. By the way, there's a variation on this step that I'm going to show you soon. So here my du would be 2x dx. And so 1/2 du using my x dx. So this guy here gets replaced by 1/2 du. So this integral becomes 3/2, because that's from that 1/2 du replaces x dx. What am I left with now? 1 over radical u, right? Now I basically say ignore the limits till the end. You sort of carry them along with you, but you emphasize that the limits go with the x and not with the u, right? So I'm just going to tag them along until the end, right? So this one looks like one of our rules. That's just a power rule. And so we know how to integrate that. You add 1 to the power, you get a half. You divide by the new power, you get 2. This cancels. Right, so at this point you can plug this guy back in. So this is just 3 times 16 plus x squared to the 1/2. And now you just plug in, perform the fundamental theorem calculus, plug in the upper limit. Minus, plug in the lower limit. That would be 16 squared plus 3 squared, that's 9. So that's 25 squared, which is just 3 times 5 minus 3 times 4. So that's just. So that's one way you can approach it. Just do everything as normal. Ignore the limits. Just carry them with you until the end when you replace your. This step is called back substitution. I don't know if I told you that last time. This step is called back substitution. Right? So you back substitute and then just use the limits that you're given. There's actually another way to attack this problem. That some people might prefer, and it's to actually change the limits themselves. And this one does not require back substitution. So we have this integral 0 to 3 of 3x over the radical of 16 plus x squared dx. Right? So now we're going to do that substitution. U is equal to 16 plus x squared. Right? This means your du, as before, is 2x dx. So we know that 1/2 du is equal to x dx. And at this point, you can also, since you solve for the u, you solve for the du, now you can change the limits, right? When x equals 3, right, which is the upper limit, what is u equal to? Well, you use the substitution equation, right? U would be equal to 16 plus 3 squared, right, when x equals 3. So that's just 25. And when x equals 0, your u would just be 16 plus 0 squared, which is just 16. Right? So you use the substitution equation to change the limits. And now what this integral becomes is the integral of 1 over radical u du, 3 over 2. But now I can actually write new limits here. This limit here is 16, that one is 25. And so now this is a problem in u. I can integrate this 3 over 2. This is u to the minus 1/2. So this is 3 over 2 times 2 u to the 1/2. Between 60 and 25, these cancel. So this is just 3, plug in 25. Minus 3, plug in 16. And again you get 3. So you can change the limits before and just forget about x's. Once you change the limits, you only care about u's. If you keep the limits, the old limits, you'd have to go back to x before you plug them in, because the original limits dealt with x, right? So there are two options on how you can do definite integrals. I won't force you to do one way or another, but personally, if you're interested, I do method 1 unless, and this is a strong unless, it's a trig substitution. This you'll learn in Math 202. Don't worry about it right now. Right? But trig substitution is one of those things where the back substitution step is really annoying. So if you can avoid doing the back substitution step, I would do it. So I pretty much do method 1 unless it's a trig substitution, then I go through the trouble of changing the limits. But that's just personal case. You can always change the limits or never change the limits. It's up to you. But I just wanted to show you the variation on how to do these problems. Do you have any questions on either of these? One, you keep the old limits, just keep you don't change the numbers, the 0 to 3, you just keep it. Okay. But at the end, you have to plug in back the x in, right? You can't plug them into the u's because they didn't deal with u's, they start with x. The second method, I changed them to be in terms of u's, right? So I took that 0 to 3 and I transformed them into 25 and 16. So I don't have to go back to x, I can just use these in the u's. One method isn't more right than another, it's just personal preference, what you like. Other variations. This will also help you mostly in Calc 2, but I guess in Calc 1, if you ever see the need for it, it might be something handy. It's to get your integrals to look nicer that you have to deal with. So, for example, what if I let u be the radical of 16 squared? Would there be any objections to this?
Yeah, we'll make it worse, wouldn't it?
No, you could do that.
I mean, you could do it, but I'm saying, wouldn't it be more work?
I could go through this and it would look ugly, but it will get me to something nice. But look at this little maneuver here. Square both sides. That looks nicer. I don't have to differentiate a radical. But what happens here? Now I have to differentiate both sides, right? What's the derivative of u squared? 2u du. Derivative of this is 2x dx. So in other words, u du is just x dx. So this integral, I can replace it by doing the following. So my 3 is out here, x dx, instead I just write u du. Right? Now what's underneath?
U.
It's just u. So integral of 1 is all I have to do. Right? So if you didn't want to deal with 1 over radical u, making your substitution a little bit more fancy a lot of the time does work. Right? And so the integral of 1 is just, of course, u. And my u is just the radical of this. So it's just 3 times 16 plus x squared. Right? That would be the answer.
Wow.
Right? So it's, you vary your substitution a little bit, get a little bit fancy, and it can make things a lot nicer. Where something like this really comes in handy is going to be on examples like that. Now, probably if you encounter that integral in Calc 2, your professor is going to recommend, depending on the professor, recommend a trig substitution, which is going to be a nightmare. Okay? It turns out that regular u substitution can work if you get a little bit fancy and you do this substitution instead of taking what's underneath the radical, take the square of what's underneath the radical. And this guy is actually not that bad. But there's a little hiccup here, and I'm going to show you how to deal with it. So here I do a u squared substitution, right? Let u be the radical. So this means 2u du is equal to 2x dx, just as before. But now what's the problem? There's an x cubed. How do I deal with the cube?
Wait, what? Oh.
So it turns out the trick is to recognize that x cubed is really just x squared times x. This guy I can replace with u du, right? What about this guy I know is just u, right? So this is just u, this guy is u du. I still have an x squared left over. What do I do with that?
It's x minus x.
I can solve for it, right? This is x squared. What is x squared is the question. Well, we'll just come over here and solve for it. X squared is actually u squared minus 16. So then I can take this and plug it in here. So now what does this integral become? 3 times u squared minus 16 times u du divided by u. These u's would cancel. This is just 3 times u squared minus 16. And you can do the integrate that. So this is just u cubed over 3 minus 16u plus c. So this is 3. My u was the radical of this, so this is 16 plus x squared to the 3 halves over 3 minus 16 plus x squared to 1 plus c. And I can assure you, when you learn trig substitution in Calc 2, I would not finish this problem until way over here. Okay, but it's just, it turns out that if I made this the 4th power, then this method wouldn't work. Then that sucks for you. But if one power is even and the other is odd, a substitution can usually work. You just manipulate this equation a little bit to substitute out any guys that are left over. But I just thought that would be a nice thing to show you just how you can vary your substitution. And trig substitution is going to be one of these ways where you can vary. So you don't just have to let u equal something. You can let u squared equal something, u cubed equal something.
How would you just know that it's not going to work?
Huh?
How would you just know that it doesn't work? Like you said, if you made it to the fourth power, like how do you know it just won't work?
Yeah, well, what would happen if I made it to the fourth power? I would break off an x, but then I'd be left with an x cubed. Right? And then if I try to replace that x cubed, I'm going to get 16 plus x squared to like the 3/2 power. And that's sort of, it will be nasty. So, I just thought I'd show you guys that. You really appreciate it in Calc 2, but you'll find opportunities in Calc 1 to do things like this. Test 4. What did I actually do? A bunch of integrals. I believe I asked for 5, and 2 are definite integrals. So 3 indefinite, 2 definite. 2. I don't remember the order. I know I asked about Riemann sums. The finite case, right? That's where I actually to approximate by right hand or left hand or something like that with, 2 or 4 starting totals.
Wait, what do you mean 5 into indefinite integrals?
Huh? 5 total. 2 are definite, right? 2 of them have numbers on the integrals, and 3 of them don't. I'm also going to ask about the infinite case. Find the exact area.
Wait, do we have to finish the limit?
Yes. By taking limits. So that you'll definitely have to know. I think that's one question. So part A is like approximate, and part B says find the exact area. 3. Actually about area under a curve. On a given interval. So I'll tell you the interval. I want to find the area under that curve on that interval. I believe that was part A. Part B of that question. I used second fundamental theorem. Calculus. That's the one that says, if f of x is an integral, then the derivative is just the original function. And of course, the chain rule version and the chain rule version. Which means if f of x is a constant up to a function, f of t is t, then the derivative is just f of g of x times g prime of x. And of course, you should know ways to switch the limits if you have to, or anything like that. What else did I ask? Average value. On some interval AB, and you can remember that that's just 1 over b minus a times a up to b. That was part A. And then part B asks about the mean value theorem for integrals. Which basically says, if your function is continuous and all that, there is C in the open interval such that f of C is the average value, right? So you're going to set f of C equal to 1 over b minus a to b of f of x dx, which you would have found the answer to that in part A, and then solve for C. Five. Five is the distance velocity problem. So I asked you about things like total distance traveled, displacement, and some other things. It's very similar to applying sine and finite. Is it speeding up, slowing down? What direction is it moving in? Things like that I like so well. And that would be the test. For B, this is mean value theorem for integrals. Well, this is it. There is C such that this is true. Right? There is a value such that the function takes on its average value. The average value is given by this equation. Right? But basically we're saying there's an x value in this interval where the function, the output, is actually equal to the average value. So you just have to find that. Bonus on 5.
Seriously?
So it covers 5.1 to 5. I want to say 4.
Which is exactly
Pretty much the stuff in the boxes. It's bonus. It can be whatever I wanted to. Right? You can still get 100 without doing this, in theory. Stuff in the boxes, FYI, if you're going into Math 209, you will be expected to know everything in 5.2 to 5.4. Right? So day 1, they expect they can ask you any question from this and these sections, and you should be able to do it. Right? So this is talking about 5.1 talks about the derivative of inverse functions, and 5.2 to 5.4 talks about logarithms and exponential functions. How do you differentiate logs? How do you differentiate exponentials? So, you know, the main stars are the functions like ln x and e to the x, right? So you learn to deal with functions like that. How do you differentiate them? How do you integrate them? And how do you integrate general terms such like log to the base a of x or a to the x, where a is a constant, right? Right? How do you differentiate them? How do you integrate them?
Wait, is the integration of e to the x 1 over x to the x?
No, the integration of e to the x is itself. And the derivative is itself. The derivative of this is 1 over x. Right.
What about the derivative?
So this actually gives you the missing case for the power rule, right? Remember the power rule didn't work when n was minus 1? It's because that guy is when n is minus 1.
So derivative of that is m plus.
So we know integral of x to the n dx is equal to x to the n plus 1 over n plus 1 plus c. count before minus
Why did
1.
I ask that?
If n equals minus 1,
If you meet it now, when we start count 2, we'll be able to have.
the answer to that is ln x. You do it in Calc 2. It's in chapter 5. It's going to be one of the first things you do in Calc 2. Dealing with
I have no idea what's happening with that.
Yes. So, any questions on chapter 4?
Oh, right. Yes, over.
I guess in particular, ones that do with the topics I say would be Huh? Anything you want.
You're almost done with the notebook.
I'm already done.
With the notebook?
This is my second one.
Wow.
Wait, no one writes this.
I don't really have
Oh
a
god.
I don't really have a
Okay, so this is from homework 4.1.
I got like 2 binaries, but I never got.
areas in the
And A says right hand, B says left hand, C says midpoint. D says sketch. They usually don't ask you on finance to sketch in this section, but okay, how do we do this one?
2 minus -1 over 3. Get the delta x.
Right, so delta x equals b minus a over n. This is 2 minus -1 over 3. So that's just 1. So we're on our interval from -1 to 2. I want to jump by size 1. Right, so this brings me to 0, brings me to 1, and then 2. Right? So these are my 3 subintervals. So in part A, if I'm taking right-hand endpoints, these I would pick these two, right? So then the area is approximately equal to delta x times f of 0 plus f of 1 plus f of 2. 1 times f of x is 1 plus x squared. So this is 1 plus 0 squared plus 1 plus 1 squared plus 1 plus 2 squared. So that's just 1 plus 2 plus 5, 8. And that's for the sketch, so I guess it'll give it to them. What does 1 plus x squared look like? This parabola, right?
I have a question.
Yes.
If it's from 0 to 2, are you supposed to draw the whole thing anyway?
Yes. But this one's from -1 to 0.
Do you subtract the rest of it, or do you keep it anyway?
No, you keep it. You have to use the interval that you're given.
Okay.
But we're using the right side to get the end point. So this one on the right will go from 0, and we draw the rectangle here. Then we go from 1,
Oh
draw
god.
the rectangle here. We go from 2, draw the rectangle here. So that would be a sketch of our approximation.
I have a question again.
Yes.
So when -1, why is it under? Is it supposed to be over since it's right?
Where'd you get that?
Right doesn't mean over or under. Right means on each interval, you look at the right side to give you the height. So on this interval, -1 to 0, the right side is at 0. That defines the height of my rectangle. On this 0 to 1, I go to the right, and up until I hit the function, that's my height of the rectangle. On this one, go to the right, that's the height of my rectangle.
Definite is there.
So right doesn't mean over. It just might happen to end up being over. Part B, we want to do left. Alright, so this is from -1, 0, 1, 2. We're taking the left-handed points. We'll take this one.
This is right.
Delta x times f of -1 plus 0 plus f of 1. 1 times 1 plus -1 squared plus 1 plus 0 squared plus 1 plus 1 squared. That's 2 plus 4, that's 5. If we wanted to sketch that one, -1, 0, 1, 2. So in this one, you use the left side to get your endpoint. So I'm between 0 and -1. This is on the left. That goes up. On the cross, that goes up. 0 is on the left. That goes up. On the cross, my rectangle. 1 is on the left. That goes up. Cross. So you can see this area is smaller than that area. How do we do the midpoint one? You find the midpoints of these guys. What's the middle of this one? -0.5, right? If you're not sure, you average these two numbers, right? And then you keep adding 1 to that. So this is 0.5, add 1 to that, get 1.5. And now you're using these guys in your function. So, I don't know, maybe writing this as -0.5 and 0.5, and 0 to 2 would be better. So here my A is approximately equal to delta x times f of -0.5 plus f of 0.5 plus f of 0 to 2. And if I wanted to draw this one, so here I take the middle, and that's how tall I make my rectangle. Here I take the middle, that's how tall I make the rectangle. Middle.
Why don't we always do the middle? It seems more accurate.
Well, on this kind of function it does. Yes.
Two questions then. So, you're not supposed to do a 6 rectangle thing?
Well, that was in part D. It says repeat with 6. Conceptually, there's no difference.
Why did you write it now? Fraction. Because I got my answer in decimal.
Well, I was squaring, and I am not allowed to use a calculator, so I want to practice. To me, squaring decimals is harder than squaring fractions. Personal preference.
So I have to write it either way.
Yeah.
Okay.
As long as you're at 1.5 and you square it and you get the right answer. Sure.
Okay.
Can you find the real value for this? Exact area?
Yes, the exact area is equal to minus 1 to 2 of 1 plus x squared, the definite integral.
And they just plug in this?
Well, you integrate it, then you plug it. Yep, so. So this would be 2 plus 8 over 3 minus 1 minus 1 over 3. So that's 3 plus, this is 8 over 3 plus 1 over 3, so that's 9 over 3. The actual area is 6. So in this particular case, right hand gave me an overestimate, left hand gave me an underestimate, and this one also gave me an underestimate. What is that? That's also an underestimate. Huh?
What was it from the tangent line stuff to find out what's under or
Well, I think the point of this problem was for you to look at the sketch and sort of judge. You can see that the rectangles here took up more area than they did. Well, this one, most of them were underneath. This one was kind of weird to tell, but it seemed more accurate than the other two. And if you look at this number, it was more accurate. You can sort of tell. But if you're ever not sure, you can find the exact answer, then you can.
usually go from the 17.
In 4.1?
Yeah.
What did it say? So determine the region whose area is equal to You won't need anything like this for the test and probably not for the final. Do you guys care still?
No, we don't. We don't.
Wait, we don't need to start finite, you said?
No. What if I did this?
So why do you sign it from home?
It's an important concept, but if you're pressed for time,
Because this will show up in
did
instead.
that help?
No.
I think yes, kind of worse.
Why did I do that? Remember there's something I'm trying to match it up to, right? B minus A over N times F of A plus I delta X. That's what I want it to look like. So what is this telling me here?
How could you do that?
I over 4 is 0.
Go pi.
This tells me that B is pi over 4, A is 0, right? And what is my f of x? It would be 0 plus I times delta x, so it's just tangent x. So this infinity of pi over 4 and tangent of pi over n equals the area under tan x on 0 to pi over 4. So that was your region. If you draw tangent x between 0 to pi over 4, that's the area we're finding. Yeah. But that was algebraic manipulation. It wasn't. This is the answer.
Oh, okay.
It says identify the region. This is the region. This part under tangent. Other questions? Where's Jason? Sunil.
Oh, yeah, okay.
Yeah, his last name like a first name. I always think of him as Jason.
No, his name was Walker Jerome. Get it?
What?
His name was Walker Jerome. No?
Okay, other questions? Are you okay with average value, mean value theorem?
You do two for
Can you do mean value theorem question? With the
Well, what's 4.2? What did 4.2 talk about?
And then on the left, the notes you need to state.
The what?
The notes,
Oh, the concept stuff? Yeah, what about it? What, the whole thing? Like, you can't go over the whole thing, like, you have to ask me specific questions.
The question I have is f of x equals x squared.
This is probably, this is actually a problem from homework?
Yes, problem 2 from 4.2.
4.2, okay.
So f of x equals x squared minus 2x.
X squared minus 2x, okay.
Interval 0 is less than or equal to, oh, not like that.
Oh, interval.
Yeah. 0 to 3. Yeah,
Okay. And
and
what's
n equals 6.
n equals 6?
Yeah, and it says find the Riemann sum, or like something like that. Yeah.
To find the Riemann sum?
Yeah.
That's a 4.2 question?
Yes, I'm sure. Yeah, it is.
what number is it?
Did it say right and then?
Yeah, it's just right.
See, that's the same thing over there.
Yeah, it's just like the. It says, what does the Riemann sum represent? Illustrate with diagram. So is Riemann sum the.
Yeah, you just do the same thing that we were doing here. Where you're doing 6 times. Yes.
That's considered the Riemann sum?
Yes. If they give you a finite number n equals 6, they want you to do this 6 times. You cut it up into 6 pieces. And just do that.
Okay.
But what does it mean? Well, if you graph this, what does x squared minus 2x look like?
Oh, it looks like this. It's a parabola, but
It's a parabola,
like
goes
under
through
the side.
0 and 2. And we want from 0 to 3. Right? So basically this Riemann sum is approximating this area. The Riemann sum approximates. If I call this A1 and that A2, it approximates A2 minus A1, right? Right? It gives you the net area under the curve. But then you just do this for the first one.
I didn't understand what professor said. That's why I didn't understand what Yeah, that's not what I said. Like Riemann sum, I thought it was triangle x, and you're supposed to find triangle x. And that's not possible because that's such a simple little thing.
You can. If you're doing Riemann sums, you'll just have the interval between 0 and 3. Delta x would be b minus a over n, which is a half. So you go to a half, 1, 1.5, 2, 2.5, 3. And if you're using right hand, you plug in these guys. So the Riemann sum from right hand at 6 is approximately equal to delta x times f of a half plus f of and then you'll get an answer, and they say, what does the answer mean? Well, it's an approximation to this net area. Net area under the curve. That's always what it represents. Yeah. What is number 30?
What is
Oh, it's a really serious graph.
So we want to find 0 to 2 of p of x. We also want to find 2 to 6 of p of x. We also want to find 0 to 7 of p of x. Where g looks like this. It's 2 here and 4 here. And here's a semicircle. To 6. 4 is in the center. And then there's a little part here. To 7. And this goes across to 1. Okay, what's the integral from 0 to 2? Area of the triangle, right? So that is asking you for this area, right? Because it goes from 0 to 2. So area equals half base times height. B. This says 2, which is here, to 6. So what's that? Pi r squared. Pi r squared over 2. R in this case is what? 2. So it's pi times 4 over 2 pi. Minus, yes. Because it's underneath the horizontal. If we have this, it goes from 0 all the way up to 7. So you want the net area of that. So the area is going to be 4, which is the first triangle, minus 2 pi, which is the semicircle, plus the other guy, which is half base times height, just 1/2, which is the second triangle. So it's well, it's 9 over 2 minus 2 pi. So this is just again testing if you understand that the definite integral is really measuring areas. So you're just finding the area. Other questions?
From 4.5. Just pick
4.5.
Just pick
Seriously.
one. I don't get anything.
Which problem?
I don't know, just any, like I don't get anything. All of it.
Like anyone? You have no
Like the
preference?
hardest one.
The hardest one, none of them.
You.
Okay. Oh, maybe this one might stop me. How about this one? Or maybe even that one. 38.
Trigonometric exception.
That's the one you just talked about.
Oh yeah.
Yeah. Trig substitution.
No, this is not called a trig substitution. Trig substitution is something a lot more horrendous.
I said
Like,
trig
you
substitution.
haven't done that substitution. It just happens that we're substituting a trig function, but that's not what trig substitution is.
It's okay. It's okay. It's okay.
So yeah, so how would we do this one? U equals sine. Right? Because it's the inside function and its derivative is outside here. Du equals cosine x dx. This means that this here is du. So now I just have the integral of sine u. Du. Do you guys want to change the limits or leave them the same? X equals 0 to pi. No, derivative of sine is cosine. Right, this part is derivatives we're doing, not integrals. When you do the substitution, you take the derivative. Oh, we have fun stuff at the end. Right. Well, it's not real fun.
Can I take it home then?
Okay, so now the antiderivative of sine is minus cosine. And so now I have to replace this guy, I have to replace the u with what it was in x because I want to use these limits. So this is minus cosine of sine x. So this is minus cosine of sine, sorry, 2 minus cosine of sine 0. What's sine of pi over 2? It's 1. And what's sine of 0? It's cosine of 0. Cosine of 0 is? It's 1. So it's 1 times cosine of 0.
That's a little value cosine.
Well, this guy I put in front.
Oh, that's 1 minus cosine. I thought that's too bad.
No, it's 1 minus cosine. 1. Radical pi, totally confusion. Total confusion. Like, if I knew how to do it with 2, I do not know how to do it anymore. It's completely different. Radical pi, oh my god. Oh my god. What happens now? I give up.
Oh, that was
It's not as
I was thinking about it. What do we do here? U equals x squared. D equals 2x dx. So 1/2 du equals x dx. So this integral becomes 1/2 cosine u du, where x goes from 0 to radical pi. So integral of cosine is positive sine. So this is sine of x squared between 0 and radical pi. So now I just plug them in. Sine of pi minus 1/2 sine of 0. Sine of pi is 0. And sine of 0 is also 0. So did all that work for numbers. 18 on 4.3. What's that? integral from 0 to pi over 3 of sine theta plus sine theta tan squared theta all over secant squared theta.
What word is this for?
Oh, that's just the integral of sine.
Wait, what homework are we on?
This is 4.3. Sorry.
Oh.
This is 18, you said, from 4.3.
Oh yeah, it's
You just
That's integral of sine. You factor out sine, you be left with 1 plus tangent squared.
over secant squared.
But 1 plus tangent squared is secant squared. Right?
And 1 secant squared is 1 over.
So this just cancels, and really I just end up having the integral of sine.
Just 1.
So the integral of that is minus cosine between 0 and pi over 3. So it's minus cosine of pi over 3 minus cosine of 0. What's cosine of pi over 3?
a half.
Cosine pi over 3 is 66.
A half plus 1. Yeah, and trigger identity.
Are we gonna have trigger density in calculus? Nah, I'm joking. Is it gonna show up a lot more?
There is so much triggering
It's
calculus.
gonna show up a lot more, right? So I should remember that.
There is so much triggering calculus. There's a lot.
Why do you enjoy saying
Like
that?
half your semester is going to be with
You know we hate it. Why do you enjoy saying that?
I'm telling you the
That's
truth.
me.
Because he can watch me do something.
This is why I forced you guys to learn to be that serious and trick because it is a lot.
Whatever we
He
hate,
can
that
watch
will
us
show up in
with
the
other
video.
professors.
That happens every time.
Did you have?
Yeah. Can you do 59?
4.3, 59.
Like the geometry never shows up. Like the angles, they never show up. And whatever we hit, that always show up. And let's say you are practicing for the finals, right? And you miss one question you practice, and
That's the one we're going to show up in the compulsory section.
that always
You
happens.
said 19, 59. What does that say? We're still at 4.3.
So we use the 3t minus 5, whatever it is. That's easy.
0, 2, 3.
So for part A, we have one position.
Position. Okay. So how do we find position function? Just antiderivative this. Right? 3t minus 5t. That's just 3 over 2t squared minus 5t plus.
Oh, no,
Did they give you an initial position?
Sorry. For part A, you have to find the displacement.
Oh, displacement. Displacement on 0, 3. Well, that's just 0 to 3 of the.
So what are we trying to look in this problem?
What?
What are we trying to look in? Acceleration?
Displacement
Displacement, no?
is the antiderivative velocity, the definite integral of velocity. So this is just 3 over 2 t squared minus 5t, 0 to 3. That's 9 over 2 minus 15. That's what? Right. So you move 21 over 2 units to the left or backwards.
Right now, for part B, they want you to find the total distance.
So for part B, total distance, that is just equal to the integral from 0 to 3, the absolute value of the velocity. So then where the function becomes negative is important, right? So we're going to look at that.
Professor, you made a mistake on A.
What?
You made a mistake on A.
A. say, what do we
3 squared is 9. 9 times 3 is 27 over 2.
27 over 2. Okay, so what is this? Minus 3 over 2. Okay, so total distance. If I set 3t minus 5 equal to 0, what do I get? Is that what I get? So t would equal to 5 over 3, which is between 0 and 3. So on this side, is v positive or negative? If I plug in something like 1, I get velocity is negative, right? If I plug in something here like, what could go there? 2. 2? Yes, 2 is bigger than that. If I plug in 2, I get velocity is positive. So total distance minus the integral from 0 to 5 over 3 of v of t plus 5 over 3 to 3. So I think we have minus 0 over 2 to the square minus 5t. So now you plug this in, it's going to be annoying. So it's minus 3 over 2, 5 over 3 squared, minus 5 times 5 over 3, minus 0, plus, this is a negative square, plus 0 over 2 times 3 squared minus 5 times 3 minus 3 over 2 times 5 over 2 squared minus 5 times 5 over 3. And then whatever.
Will there be something that
Yes. $29, 4.3. What's that? Huh? Minus 1 to 2.
X minus 2 times the average value of x. Yes.
Okay. What do you know about absolute value? When it's negative, it gives you the negative of x. So we split this up, go from negative 1 to 0, and then my absolute value of x gives me negative x. Plus, when I go from 0 to 2, my absolute value of x just gives me x. So this is just 0 from minus 1 to 0, 3x dx plus.
What's the fun thing?
What did you say?
What's the fun thing you really
What? You only care about one? We're having fun now.
I'm not having fun. I swear I'm not having fun.
We're having fun now. So,
Professor, I was confused on how can you break up this stuff?
If this is fun for you, it's not even.
because I know absolute value changes around 0. X is greater than or equal to 0. X minus x is less than 0. So this interval was from minus 1 to 2. But 0, the function switches on either side. So I have to break it up.
So is the 0 is the one number that can work in one, right?
Because of the absolute value. Yes, 0 is.
So whenever you have absolute 0 straight,
Whatever x makes that 0, yes. If I had something like x minus 2 times altitude divided by x minus 1, I would break it around 1. So this is 3 over 2x squared, minus 1 is 0, plus minus x squared over 2 between 0 and 2. Now for something everyone can enjoy. You get to tell everyone how much you love me. Surveys.
Right.
The best part.
Jawan's the best ever. Yeah, I see a lot of you want to get revenge now. So yes, we'll throw Jawan off that cliff finally. What? Well, you have to do it now. Okay, so who's done this before?
Wait, let me see.
Have you been in a class where there's a survey before?
Yeah.
I need a supervising student. So you're supposed to take the surveys, give it to her, she'll drop it off at the office.
Can I turn this off?
Yeah, you
At your office.